Hi everyone. Today we're going to study sum and difference identities. Finding the exact value of the sine, cosine, or tangent of an angle is often easier if we can rewrite the given angle in terms of two angles that have known trigonometric values. We can use the special angles, which we can review in the unit circle as shown. We have this unit circle here. There are coordinates for each of the given angles. Note that the x-coordinate corresponds to the cosine theta, while the y-coordinate corresponds to sine theta. Let's go now to the sum and difference identities. Let's begin with the sine of alpha plus beta angles. This is equal to sine alpha times cosine beta plus cosine alpha times sine beta. The sine of the angles alpha minus beta is equal to sine alpha times cosine beta minus cosine alpha times sine beta. Please note some patterns here for the sum and difference of the sines. I will go now to the cosine. For the cosine of alpha plus beta, this is equal to cosine alpha times cosine beta minus sine alpha times sine beta. For the cosine of alpha minus beta equals cosine alpha times cosine beta plus sine alpha times sine beta. Please see also some similarities or patterns for the sum and difference of the cosine. I will go now to the tangent. For the tangent of the angles alpha plus beta equals tangent alpha plus tangent beta all over 1 minus tangent alpha times tangent beta. For the tangent of the angles alpha minus beta equals tangent alpha minus tangent beta all over 1 plus tangent alpha times tangent beta. See and observe the similarities of the sum and difference for the tangent of two angles. Let's see this example 1. Find the exact value of cosine 75 degrees. We're going to split this 75 degrees into 45 degrees plus 30 degrees. We're going to use 45 degrees and 30 degrees for the cosine because these are special angles with respect to cosine. So we say that cosine 75 degrees, our problem here, equals the cosine of the angles 45 degrees plus 30 degrees. Let's begin by writing the formula. The formula is here now. And substitute the given angles. The alpha corresponds to the 45 degrees and the beta is the 30 degrees. So we write the cosine of 45 degrees plus 30 degrees equals cosine 45 degrees times cosine 30 degrees minus sine 45 degrees times sine 30 degrees. From the unit circle, we will get the corresponding values for the cosine 45, cosine 30, sine 45, and sine 30 degrees. So we have now square root of 2 over 2 for cosine 45 degrees. square root of 3 over 2, that is cosine 30 degrees, minus square root of 2 over 2 for the sine 45 degrees, times 1/2, and this is sine 30 degrees. Simplifying now, we have square root of 6 over 4 minus square root of 2 over 4. We have a common denominator here, so we'll put this together. So we have square root of 6 minus square root of 2 all over 4. This is the final answer. Example 2. Use the sum and difference identities to evaluate sine 15 degrees. Let's note that sine 15 degrees we can write as sine of 45 degrees minus 30 degrees. So we write the formula for the sine alpha minus beta. Substituting the corresponding values, we have sine 45 degrees minus 30 degrees equals sine 45 degrees times cosine 30 degrees minus cosine 45 degrees times sine 30 degrees. Here are the values of the special angles that we need. Substituting the values now, we have square root of 2 over 2 for the sine 45 degrees, square root of 3 over 2, that is the cosine 30 degrees, minus square root of 2 over 2 for cosine 45 degrees, times 1/2, that is the sine 30 degrees. Simplifying our values here, we have square root of 6 minus square root of 2 all over 4. This is the final answer. Example 3. Find the exact value of tangent 15 degrees. In this case, we're going to write tangent 15 degrees equals tangent of 60 degrees minus 45 degrees. Our formula for the tangent alpha minus beta is here. Substituting the corresponding angles, we have now the tangent of 60 degrees minus 45 degrees equals tangent 60 degrees minus tangent 45 degrees all over 1 plus tangent 60 degrees times tangent 45 degrees. Our values for the tangent 60 degrees and tangent 45 degrees are here. We can get these values from our unit circle a while ago, considering that the tangent A is equal to sine A over cosine A. Now, let's do the substitution. We have square root of 3, that is tangent 60 degrees, and this one is the value of tangent 45 degrees, all over the constant 1 plus square root of 3 times 1. Simplifying this, we have now the square root of 3 minus 1. In our denominator, we simply put the square root of 3 first, followed by plus 1. This is now the final answer. I hope you learned something from this video. See you again next time.